Is it recording?
Yes.
I'm sure.
No, I don't say.
Okay, but I did not share. Let me share. Yeah, I know it's recording. Let me try to share. Fine. Is anybody check? Okay, I'm assuming it's fine. So we are going to do something interesting today, panel data. You guys, will like it? It's good, right?
It's too much.
Instead, it's good. By the way, Ikra, are you now fasting? Are you fasting now? Are you now fasting? You are just smiling, you're not answering. You don't answer a question with a question. You answer a question with an answer.
Clever people do.
No, you don't answer a question with a question. Answer me first, and then you can ask your question.
He's religious only applicated in his country.
He's religious only in Cameroon.
Yeah.
Ikra is only Muslim in Pakistan. Okay, done.
Okay. But do you still go to the canteen to eat? Do you still go to the canteen to eat? Because I saw you eating in the canteen some time ago, Not today, some time ago. Some days ago. Yes, it's recording. Can you check? Okay, today, guys, we are going to talk about panel data, right? It's quite interesting. So, what's panel data? Who has an idea? Panel data.
It's a mixture of time series and construction.
Okay. As you know, we have three main types of data, right? Time series. I will not write on the board because I want everything to show in the record. Time series data. What else we have? Cross-sectional data, and of course, panel data. You know these things. So, what's the difference, by the way? What's time series data?
It focuses on one country for several time periods.
One subject for several periods.
Yeah. It must not be country. It can be anything, but yeah, one subject. So with time series data, we are dealing with just one subject, or one, you can say one entity over a period of time, over a time span. Cross-sectional data.
Different entities over 1 billion times.
Subjects for, no, yes.
Yeah, 1 billion.
Yes. Different subjects, entities, whatever you want, at a particular point in time. That is just one period. So, for instance, here, as an example, I can say the impact, just an example, the impact of what? Financial development on GDP from, or let's say, for the case of Nigeria. Don't ask me why I chose Nigeria. From 1990 to 2020, just an example. So don't look at GDP and FD as the entities. No, these are variables. Our entity here, our subject here is Nigeria. We are studying just one country. Then we are studying it over a period of time. We have a time span. That's time series data. One subject, many years, right? Cross-sectional data, as you rightly said, we are studying many different subjects, but just for a particular point in time. So for instance, I can say it can still be the same thing, the impact of financial development on GDP in EU countries 2020, whatever. So again, you see, we are studying so many countries, more than one, European Union countries, but just for 1 year, this cross-sectional data. Many subjects, but just at a particular point in time. So if you see with time series data, the subject does not vary because it's just one, but the time period varies because it's many, right? With cross-sectional data, the subjects vary because there are many, but the time does not vary, just one. But now panel data is, we are bringing both of them together. So we have variation both in time series and in cross-section. So it's not like we have just one period of time. We have a time span, and we have more than one cross-section. So as an example, I can say, still the same thing, the impact of financial development on GDP in European Union countries from maybe 1990 to 2020. So you discover that we have more than one cross-section. So the subject varies and the time also varies. Now this is panel data, right? So we are going to see panel data today. It's very interesting. Of course, we will do the applications, which is very easy. I can assure you, very, very easy. But before doing these applications, I'm going to tell you an interesting story. First of all, I'll tell you what you have to know, what I feel you have to know. And then secondly, I'll tell you what I am not supposed to tell you. But I will still tell you because I care about you, you know. So that's why I will tell you, even though I'm not supposed to tell you. And then we can do the applications. Okay. Now, in econometrics, okay, there is another one. We have financial data. I mentioned it some time ago, did I? We have financial data. Normally, we have time series, cross-sectional, and panel data, the main types of data. But we also talk of financial data. Actually, financial data is time series data. So it's not like it's a different category. It's actually time series data. But the reason why we put it separately on its own is because, does anybody know? I mentioned it.
Very high frequency data.
Yeah, high frequency data. Financial data is typically high frequency data. For instance,
Seconds.
yeah, you can have
Seconds.
minute by minute data. You can have data every 5 minutes. So it's high. For instance, stock prices. If you check the stock price of a company now, come back after 10 seconds and check, maybe it has changed. It changes all the time. It's high frequency data. And because of this high frequency data, it has so many problems. Each of these categories of data have their problems. For instance, in time series data, the biggest problem is autocorrelation. That's the biggest problem in time series. It is not the only problem, but it is the biggest problem, I can assure you. In cross-sectional data, the biggest problem is heteroscedasticity. Now, panel data, because it has elements of cross-sectional and time series, so it also has its problems. It also has autocorrelation, heteroscedasticity. There are also things like cross-sectional dependence, slope heterogeneity, but don't bother about that. But what I'm saying is that time series data has this autocorrelation and some other problems. Financial data, even though it is time series, but because it is high frequency, it has some additional problems. For instance, it has the problem, and you'll see it on Tuesday with Nigahoja, it has a problem of volatility clustering. Volatility clustering. Also have problem of non-linearity. So that's why, because of these problems, because it is high frequency data, that's why we put it alone, financial data, right? Okay. Now, I'm not going to get into this today because we'll see it after the midterm. So actually, what is happening is that today we are seeing panel data. On Tuesday, you will do volatility with Nigahoja. And you know, next week, Friday, we don't have tutorials, right? because there's this Bayram thing and there'll be a lot of food and drink. So I'll be somewhere enjoying myself. I'll be eating and drinking a lot on Friday. This coming, I can't wait for Friday to reach, you know. So of course I'm not a Muslim, but I have to celebrate, and I'll eat and drink even more than you guys, the Muslims. So because we have no class on Friday, so you will not be discussing volatility with me, but you will do everything with Niga Hoja on Tuesday, including the practical, because you know, in fact, this is our last session until after the midterm. And after the midterm, we'll start doing time series. So no time for volatility with me, but you do it with Niga Hoja. Of course, I learned from Niga Hoja, so you will be doing it with the boss, which is good for you.
Can't you give us like a small section of it?
When actually, you can ask her to record. She will. Why won't she record?
Because she I think she's having so much on her table, just recording for us. She just explains that really details.
Yeah, but I spoke to her and she knows we cannot have the session next week Friday because I told her that I'll be eating and drinking on Friday. So she will do, Niga Hoja will do volatility on Tuesday, both the theory and the practicals.
So maybe you can like this that on Tuesday we can ask time series like the previous class that we came to our class. Remember, we took 1 hour and we recorded the session with us.
It took 2 hours.
Yeah, for
No.
so maybe you can do something like that.
Okay, I'll think. Yes, but as it stands for now, I'm giving you the program. We are doing panel data today and we are finishing it because it's not even long. Because we'll do just a regression, we'll not do the other things. Well, not tomorrow. On Tuesday, you will do volatility with Niga Hoja. And then after the midterm, we'll do time series. Time series is quite interesting. I love it. But after the midterm, we'll do it. So many interesting things. Okay. Now, what I'll tell you is that with cross-sectional data, if you have cross-sectional data and you're trying to do a study, you're trying to do something, you can directly use regression. You can use regression. You know regression, right? If you use regression, no problem with cross-sectional data. But with time series data, you cannot use regression directly. Why? Because time series data has some problems. Okay, autocorrelation is the biggest problem, but in time series data, there's a problem of stationarity. Okay. I'm just giving you some brief ideas, then we'll do panel data. So, stationarity. Did I spell it well? Okay. After the midterm, we'll see more about this. So, you know, because this data varies over time, the data might not be stationary. Don't ask me what stationarity is because I will not tell you until after the midterm. I don't want to divert. But just know that because of the problem of stationarity, we cannot directly use ordinary least squares with time series. We have to, yes?
Isn't stationarity is referred to the frequency of the data,
No.
like the variance of it, how it moves, if it's stable or it goes up? The upward, the trend upward, or like if it's stable?
Stationary, you're asking me to define stationarity. If data is stationary, it means it has constant variance, constant mean.
Like it doesn't go upward, it's just constant. Like it's
constant.
A limit, which is related to the normality thing.
No. Stationarity has nothing to do with normality.
Yeah,
or
just like similar to it.
Anyway, don't bother, we'll see it after the midterm. But just know that stationary variable has a constant mean, it has a constant variance, and it has constant autocovariance. Don't bother about that. Okay, now because of the problem of stationarity, the first step in time series analysis is to run unit root tests. When you have time series data, the first thing you have to do is you should run unit root tests. Now, why are we running unit root tests? Because we are trying to check if the data is stationary or not, right? Now, this data for unit root test, we'll check it both at level form and first difference. I told you what first difference is, right? If you have the data, the raw data, it is the level data. But you can transform it to first difference. I told you how you get first difference using the lags. I told you go and check previous records. So we'll run this unit root tests for each variable at level form and also at first difference. Now, depending on the results we'll get, it will tell us what method to use. Okay, if in a study you have many variables, right? So if all our variables are stationary, by the way, if a variable is stationary at level form, we'll say it is I0. I0 means it is integrated of order 0. But if it is not stationary at level form, but stationary at first difference, then we'll say it is I1. You may get confused now, but don't bother yourself. Okay. So if a variable is stationary at level form, it is I0. If it is stationary at first difference, it is I1, right? Now, we can have three cases. I'm just trying to give you an overview, then we'll go to panel data. We can have three cases. We can have the case where all the variables are I0. Have the case where all are I1. This thing is difficult to write. Oh my God. We can have mixed. So if we run these unit root tests to check the stationarity of the variables, and we discover that all the variables we have are I0, which means all of them are stationary at level form, in this case, we will directly use ordinary least squares. So that will be the method we will use. Now, if all of them are stationary at first difference, that is, they are non-stationary at level, but they are stationary at first difference, which means they are I1, all of them. In this case, we will do a method called co-integration. I will not get into it now because we are not doing time series. We'll do co-integration. But if we have a mixed order of integration, which means some of the variables are I0 while some are I1 mixed, then we'll do ARODL. ARODL stands for autoregressive distributed lag, but that's the method we'll use. Okay. So we have seen basic regression, ordinary least squares, right? But know that if you're working with time series data, you are only allowed to use ordinary least squares if all your variables are integrated of order 0. So first of all, you have to conduct unit root tests to check the order of integration of your variables. Depending on the results you have, you will know the method to use. That's it for time series. Now, with cross-sectional data, we can directly use ordinary least squares regression, no problem. Okay, I'll talk about panel, but let me talk first about financial data. Like I told you before, financial data is actually time series data, right? But because it is high frequency data, it has some additional problems, especially the problem of volatility clustering. Because of this problem of volatility clustering in particular, we cannot model financial data using these conventional time series methods. These are conventional methods. So we have to model financial data using different methods which account for this volatility clustering. That's why to model financial data, we'll use ash-gash methods. And you're going to see this on Tuesday, volatility, ash-gash methods. And with this, you will not use eViews. There's a different software you use. This is the software Osmetrics. This is it. Osmetrics. You use this software. Okay, so that is it. Now, if you have this kind of idea, then we can talk about panel data. So I just, sorry? Hausmetrics, this is the software, very good software. Let me open it to see. Barish, I think you can get it from Barish. He has it. So it's a nice software, but anyway, we are not doing volatility. So that's what you will use for volatility, right? So now panel data. We'll see panel data now. I just wanted to give you an idea of what is happening. So now we have defined panel data, right? And why do you think we are supposed to use panel data? Like, for instance, instead of doing this study, instead of saying the impact of financial development on GDP for Nigeria, why would I come and say the impact of this for European countries from this? Because it's the same time period, right? Okay, let me not put Nigeria here. Let me put a European country. Let me put Germany, for instance. So instead of doing this study for Germany, why would I want to do it for all EU countries? It is the same study, the same time period. But instead of using one case study, why would I want to do all EU countries? So why should I use panel data? Why should I not use time series data? What do you think? Yes, that's one reason. If your interest is the group, because you know, if we do this study for Germany, we'll get results for Germany. We'll get the relationship between financial development and GDP for Germany, but we cannot say it is true for France. We cannot say it is true for Belgium, right? So by using panel data, we can get an average result. Maybe the relationship is different in Germany. Maybe it's positive in Germany, maybe it's negative in France, maybe it is not significant in Belgium, maybe it is significant in the Netherlands. But with panel data, it will give you an average result, which is true, that is the average of all these countries. So if our main interest is the group, not just a single component, then we can use panel data. Another problem is insufficient number of observations, because as you know, with time series data, we need at least 30 observations, right? 30 observations. So maybe you don't have enough data. Maybe you're trying to get data and you don't have data for up to 30 years. Maybe you have just 10 or 15 years. You cannot do a time series because your results will be biased. So because of this, you can do a panel. Okay. Now, what are the econometric methods for panel data? Why? You're trying to sleep. Everything, is it boring? I didn't say you're sleeping. I said you're trying to sleep. Yeah, you're trying to sleep. Okay, guys. By the way, are you understanding this? Are you understanding? Is it okay? Yeah, because I know it's somehow it's new. We have been doing ordinary least squares throughout, so panel data is new, but it's easy. It's not difficult, I can assure you. Yeah. What are you?
You asked a question, so I'm trying to find the answer.
Okay, you're looking at your notes.
I mean, yeah, I didn't memorize them.
Okay, so panel data now. First of all, I will show you the data. Is that not downloaded?
You did.
Balance panel, please. Yes. Okay. So look at this data. By the way, these are our variables. We have GDP, we have capital, labor force, entrepreneurship, globalization, right? So we have 1, 2, 3, 4, 5 variables. Okay, we are going to assume that GDP is our dependent variable, which means we have 4 independent variables, right? Okay, now look at our time span. It's from 2006 to 2021, right? Because 2006 is the same thing. Look at our cross sections. You see, we have China. We have China. If you go down, we have India, which is the second. We have Malaysia, number 3. Singapore, number 4. Thailand, number 5. Indonesia is the 6th. Japan 7, Pakistan 8. Okay, so we have 8 different countries, right? These are our cross sections, and our time span is, that is for each country we have data from 2006 to 2021. That's our time span. Now, when you download your data from World Bank or from wherever, this is not how the data will come. You know how to download data, right? From World Bank. It will come in a different format. You have to transpose it and everything. But with panel data, you must arrange your data like this before you put it in eViews, because this is the eViews format. So you have to be careful. For each cross-section or for each country, that is, take one country and put all the time span, put all the years. So you see, what we take China, we put from 2006 till 2021, only China, before we move to the next country. So take the first cross-section, put the data for all the years, and then go to the next cross-section or country or bank or whatever, and do the same thing. So this is how you are supposed to arrange your data before you put it in eViews. Because if you don't arrange it like this and you put it in eViews, all your results will be rubbish, I can assure you. Okay. So in this case now, you see we have how many countries? 8. And our time span is from 2006 to 2021. Okay. So I'll show you how to import the data to eViews. I'll use eViews 10. eViews 10. It's the same thing. So just come to create. Now, what should we use? Balance panel. Okay. Guys, if it is time series data, we'll use dated regular frequency, you know, right? If it is cross-sectional data, we'll use unstructured, undated. For panel data, it can be a balanced panel and it can also be an unbalanced panel. I'll tell you the difference. Now, if it is a balanced panel, then we'll use this balanced panel. But if the panel is not balanced, then we can use a different software, maybe Stata, but we can still use eViews. If it is unbalanced, we can still use eViews, but we'll use unstructured, undated. So we'll only use balanced panel if it is a balanced panel. Now, let me just tell you what is balanced panel before I continue. By the way, what is balanced panel? Nobody knows?
Frequency, time.
Balanced panel. Yes. Actually, balanced panel means that for each cross section, you have the same time span. So for China, we have from 2006 till 2021. For India, we have the same time span. That's balanced. But if for China, we have 2006 to 2021, and then for the other one, we have 2006 to 2015, and then the other one we have 2018, is unbalanced, right? So balanced panel means for each cross section, we have the same time span. Okay, let me just take this advantage and tell you something. Panel, because where are we? Because you see here, unstructured, balance. So I'll tell you what unstructured means. Where are we? Let me just use Excel. So let's say year is 2007, right? Let's say instead of this 2007, they put 2008, and then so year will be 2009 and so on. But they skip 1 year. Instead of 2006, they put 2008. That's unstructured. It's not like the years are not like in consecutive order. So instead of 2006, 7, 8, 9, maybe you have 2006, 2008, then 2009, 2010, then maybe 2014. You understand? It's unstructured. But if it is 2006, 7, 8, 9, like that, it is structured. Okay. But for balance, you know what balance means. I told you that already. So arrange your data like this, and for balance panel, we use balance panel. If it is a balance panel, then in eViews, we are using balance panel, right? Now with frequency, if it is annual data, like these macroeconomic variables, of course, we'll use annual, but the frequency must not be annual. It can still be monthly, quarterly, whatever. We have annual. So our start date is 2006, right? Our end date is 2021. How many cross sections we have? 8. Then I click OK. The next thing now is to put the command. You know all these things. So I'll type data. By the way, what are the variables? GDP capital, GDP capital, I'll just put CAP. You can use whatever you want. Labor force, I'll just put LF. Entrepreneurship, I'll just put ENT. And then, what's the other one? Globalization, I'll just put GLO. I press enter. I have my spreadsheet. So you see, look at the spreadsheet. You see 106, 107, 108, right up to 21, and then it moves to 2. So it's not like you're going to see the countries here. But when you see 1, you know that 1 stands for China, the first country there, right? And then when you see 2, you know that 2 stands for the second country, India. So this 2 here stands for the second country. So maybe in your paper, if you're writing your paper or your article, maybe you have like a footnote, or maybe like a table indicating that 1 stands for this country, 2 stands for this country. Because when you draw your graphs, you will see that those numbers there, 1, 2, you understand? Then you know what 1 stands for. So I will copy my data. Of course, just the data, and paste on eViews. Paste on the first cell, right? And I can delete. So my data is on eViews. Now let me show you what I was trying to say about the 1, 2 things. Let me just highlight all the variables. Let's check the graph. So you can just press enter, come to view. The same thing, you can check the graphs. Just come here from single, put multiple, the same thing, and check the graphs. So if you look at these graphs, I don't know, it's too small. It's too small, you cannot see it. How can I zoom? Is it possible? Okay, yeah. So you see here, you see 1, 2, 3, 4, 5, 6, 7, 8, right? So when you see 1, the other 1 is the first country there. When you see 2, you know it's the second country. When you see 3, so maybe you can draw like a table. Maybe you can indicate in a table that 1 stands for this country. These kind of things, you can do it. You can also check the descriptive statistics. Let's use common sample. So these are the average values for all those 8 countries. Like the mean, the median, you know how to explain all these things. Jack Bera we can use for normality, you know all these things, so I'm not getting into that. Okay. So also we can use logs, and it's always advisable to always use logs, because you know with logs we can express in percentages, right? So what I'll do is I'll generate lane GDP equals log GDP. Same thing, there's nothing new. So for the others, I will just change it GDP CAP. Just do it fast to save time, because we have to get into interesting things. Labor force. ENT, GLO, and GLO. Is there anybody who does not know this thing? How to generate log? We need to lock the person up. Is there anybody who does not understand? Okay, so I've generated the logs. So now we are going to see how to estimate the panel data and how to interpret it. But before doing that, I'll go back to Microsoft Word and I'll tell you something interesting. So guys, again, now what I'm telling you, this one is just for your information. And I'm insisting because we are not going to do it. And I'm not even supposed to tell you, but I'm telling you just for your information. Because I feel like most of you will continue with PhD, right? And you will still do this thing. So even though you will not know what these things are, but at least the names will not be surprising to you. For instance, some of you will be writing your thesis this semester, next semester, you'll be doing literature review. You'll be checking the literature. You'll be seeing how they are using these methods in the papers. You'll get confused, but at least if you have an idea of what it makes your life easy, right? Okay. Now, with panel data, what we have to do is the first step. If we have panel data, the first step we have to do is we have to run two tests in particular. Well, three, but we'll start with two. Cross sectional dependence. Did I spell it well? First test will run cross sectional dependence test. We are trying to check something. Trying to check if there is cross sectional dependence anyway. After that, we'll run slope hetero. I don't like spelling these things. After that, we will run slope heterogeneity test. There are reasons why we are doing this test, so don't feel like we are just doing it because we want to do it. But I'm not telling you why, because I don't want to get into the details. I just want you to have an idea so that at PhD level, you will not face difficulties. And if you're reading the papers to do your literature review, at least if you see in the paper they are doing these tests, you know where it's coming from, right? Now, after this test, we are going to do unit root tests. Same thing. If you notice with time series data, we started by running unit root tests. And depending on the results we have, we will know which method to use, right? So same thing with panel data. Actually, we are supposed to start with unit root tests. And depending on the results we have, we will know what method to use. But the issue where we are running these first two tests before unit root tests is because this, especially this first one, it will tell us the type of unit root test to use. So there are some unit root tests which account for this cross-sectional dependence, right? So we should first of all check if there's cross-sectional dependence, if there's slope heterogeneity, because when doing our unit root tests and other things, we can account for them. Okay, now, after running the unit root tests, we can have three sets of results. We can have three cases, just like with time series. We can have all I1. We can have all I0, and we can have mixed. Same thing. Now, so with unit root tests, we are trying to check if there is stationarity or not. Now, we can discover that all the variables are stationary at level form, which is I0, or maybe all of them are stationary at first difference, which is I1, or maybe some are I1, some are I0, which is, in that case, we say it is mixed order. So depending on which one we have, it will tell us the method to use. Okay. If all of them are I0, then we'll do panel regression. Panel regression. If are I1, then we'll do panel co-integration. And if we have mixed order, then we'll do panel ARODL. Same thing with time series. If you see time series, I0 regression, panel I0 regression, time series I1 co-integration, panel I1 co-integration, time series ARODL if we have mixed order, with panel ARODL, right? So for this course, we are not going to do co-integration and we are not going to do ARODL. This is the only thing we'll do, and we'll do it now. We'll do panel regression, right? I'm not going to show you any of this. Cross-sectional dependence, slope heterogeneity, panel unit root. We will not do any of this. But at least I'm telling you, so you should know the procedure. You should know that even though we'll do panel regression now, but you should know that if you're trying to do your study or something, you can only do panel regression if all your variables are I0. And you will know if it is I0 or I1 by running unit root tests. So this is just for your information. Okay. By the way, after the midterm, with time series, we'll see all of this. We'll see them. So now, with panel regression, what we'll do today, let me copy and paste down here. With panel regression, actually, to estimate panel data, we have 3 methods, which I can tell. There are many methods in econometrics, many, but I can tell you of, actually, I'll mention 4 things. Seemingly, you have any idea this? You ever seen this somewhere? Seemingly unrelated regression. Not seen it anywhere? Okay, no problem. Problem?
Oh no, I'm just surprised.
Don't be surprised, you know. Good regression. Guys, don't bother. It's like I'm saying so many things, but don't get confused. I'll explain. And if you don't understand, please ask me. Everything I was telling you before is just to give you an idea, but now we are getting into the real thing. Now,
That is another one.
sorry?
There's time fixed effects model, right? The same.
I'll explain, don't bother. Now, we have these 4 methods. This first one, pooled regression, is not actually a panel data technique. It is ordinary least squares. It is the basic ordinary least squares we know. So when we have our panel data and we are running pooled regression, what does it mean? It means we are just bringing together the data. You know, panel data, we have data for different countries, right? So we are just bringing the data for all these countries together, like in a pool, and then we just run the regression. That's what it means. We are not using any panel data technique. Now, these 3 are panel data techniques. Seemingly unrelated regression, we have fixed effects model, and we have random effects model. Now, as he has mentioned, under fixed effects model, we have time fixed effects and we have cross-section fixed effects. I'll show you on e-views. Now, we are not going to talk about this one, seemingly unrelated regression, because it has so many problems and it is outdated. Nobody uses it again, right? But I just mentioned it, so at least you should have an idea. Nobody uses it. It's outdated. What have I done? It disappeared. So this method, nobody uses it, so we are not going to use it. So I am putting it red. We are going to focus on pooled regression. No, if it is important, I'll put green. Red means error. So I'm going to focus on pooled regression and then fixed effects and random effects. But guys, pooled regression is not panel data technique. But we use it when doing panel data because we are bringing pulling the data together and we are trying to treat it as one data. Like we have data for different countries, different cross sections. We pull all of it together and we try to treat it as one data. It's just regression, right? So we are not accounting for the spatial characteristics of the data. But by using fixed effects and random effects, we are trying to account for the distinct characteristics of this data. These are panel data techniques. Okay. Now, what should I tell you? I'm telling you too many things.
Yeah.
Sorry about that. Guys, okay, let's go to e-views. I'll come back. Now, let's run. Yes. Break? You want break? We have not done anything.
What's left? Just the application?
Yes. Really? So I should stop recording?
No.
And then when you come back, I continue. Why break? Why you want break?
Anyway, I should
Okay.
You should leave.
not now.
Okay, 5 minutes break is okay. Okay, 5 minutes break and then we can do the application. Okay.
Thank you so much.
Yeah, you can take break. But I'm surprised why you need break. I'm surprised why you need break.
Really, I don't need what I can see.
Okay, 5 minutes break is okay.
There's a lot of process.
Or 10 minutes you want? I can give 10 minutes if you want. If 5 minutes is too small. Okay. Now is no 5 minutes. Now is 1:20, 1:28. Okay, let's say 1:35. 7 minutes. 1:35. We can do the application.
You want anything coffee, please?
You want? Yeah, with sugar. I like sugar.
Coffee?
Coffee has to.
Mr. Brown.
Coffee has to be hot, you know.
Okay.
Why cold?
Okay. I will get you one.
Break it. Now you can break it.
Okay, let's continue. Please, guys, everything I've told you so far is just for your information, right? For panel data, we are going to focus just on the practicals in this course, as far as I know. The theory and everything is not too important for this course, but I'm telling you just for your information, so don't take it too seriously. And the reason I mentioned it is because most of you will do these things in PhD, so it will not be like you are hearing it for the first time. And if you're reading some of these articles to do your literature review, if you come across some of these names, at least you should, you know, if you see something you have heard before, you are not scared, right? So it's just for your information. So now we are doing the panel data. Now, as I have told you, with pooled regression, it is not a panel data technique. It is actually ordinary least squares. We are pulling the data from the various cross sections together, and we are treating it as one data. Pooled regression. So these three are panel techniques. Nobody is using this SUR anymore, seemingly unrelated regression. It has problems. I'm not going to tell you the problems, but it has problems. So we are going to see fixed effects model and random effects model for panel regression. Now, briefly, I will tell you when to use fixed effects and when to use random effects. Okay, let's say we are trying to do this study, GDP equals to constant plus beta 1 financial development plus beta 2. What should we use? Which variable? Population plus constant. So let's say we are trying to investigate the impact of financial development and population on economic growth, right? But we are using panel data. So it means we are trying to do this study for EU countries, all the 27 countries in the European Union, not just one country. So we have panel data. Now, you know that in order for us to investigate the impact of financial development on GDP, we have to keep population constant, right? We have to hold the effect of population constant. But with panel data, there might be some other factors which will prevent us from having the pure effect of financial development on GDP, not just population. So even if you hold population constant, you might not still be able to get the pure effect of financial development on GDP, because maybe there are some other factors which this model is not accounting for. They call them unobserved. No, I'm even telling you this. Okay. Unobserved heterogeneity. Let's say unobserved factors, right? So if we have these unobserved factors which are preventing us from having the pure effect of the independent variable on the dependent variable, then we can use either fixed effects model or random effects model, but it will depend. If these unobserved factors are related to the regressors, that is, they are correlated to the regressors, then we'll use fixed effects. But if these unobserved factors are not related, that is, they are uncorrelated with the regressors, then we can use random effects. Theoretically, that is some cases where we can use random effects or fixed effects. But I will tell you that you should not bother too much about it, because it's a statistical test that we will just directly use. And this test will tell us whether we should use fixed effects or random effects. But I just gave you some theory about it. Okay. So first of all, I'll run pooled regression, which is the same regression you know. So my dependent variable is lean GDP. What's my independent variables? What are they? Let's take them in order. Capital, labor force, entrepreneurship, globalization. Capital, labor force, entrepreneurship, globalization, right? So I can just right click, open as equation, You know, I can go to quick and everything, yes, but open as equation. You can leave the constant here, or you can just put the constant at the after dependent variable is the same thing. So you see here, what's the method? Least squares. Ordinary least squares is the same regression. So just click OK and you have your results. The same thing we know. So if we do it like this, this is pooled regression. So we have just brought the data together and we're looking at it as the same, as one group, right? We are not accounting for any specific effects of the data, whether fixed effects or random. We are just pulling it together. So you can interpret it the same way. Of course, coefficients, you know how to interpret coefficients. But before interpreting coefficients, as always, you have to check statistical significance, right? You know these things. Look at the arrow squared. You know what arrow squared is. Explanatory power, adjusted arrow squared. So the same things, right? You can interpret it the way we have been interpreting ordinary least squares. But this is pooled regression. Now, I'll go back, so I'll cancel it. And now let's do fixed effects. So again, I'll open as equation. You can leave the constant at the end or at the beginning. It doesn't matter. Let's leave it at the beginning. Now with fixed effects or random effects, we are trying to account for specific characteristics of the data. These are now panel techniques. So you see panel options here. I'll come to panel options. Now, you see here cross-section, none, fixed random. Period, none, fixed random. You know, panel data has both cross-section and time series, right? So this period is a time series aspect, while this is a cross-sectional aspect. So let's start with fixed effects. So let's say with fixed effects, let's say we are trying to account for fixed effects in both cross-section. So I will put fixed, period, I'll put fixed. You must not use fixed in both cross-section and period. You can use cross-section fixed and you can use here none, but well, it depends on you, the researcher. So you can use fixed in both, or you can use it in just one, but it depends on you. Let's use it in both anyway. So that's the only. No, I say you can use both or you can use one. It depends on you.
What difference does it make?
The results will be different, but you have to explain why you use this and why you did not use this.
So from the quick you will have your option, right? Then you go to the equation estimation section.
You want me to repeat it?
Please.
Okay. Okay. I don't want to go to quick because I will have to actually manually type the variables. Okay, let's type it. Lean, GDP, constant. What's the other variable?
Lean cap.
Lean.
Cap. CAB.
Lean cap.
Lean LF.
Lean LF.
Lean ENT.
Lean ENT.
Lean GLO.
Lean GLO. So with this, after typing the variables, if I just click OK, I'll get results for pooled regression. I'm not accounting for any specific effects of my data. But if I want to account for fixed effects or random effects, then I have to come here. Can you see these panel options? Come to these panel options, then I can put random or fixed. Like if you come here, you see fixed, random. So if I choose fixed, it means I'm accounting for fixed effects. If I choose random, it means I'm accounting for random effects, right? So we are going to start with fixed effects. So I'll put fixed in cross-section and I'll put fixed in period.
In this situation, we need to choose fixed or none.
That's what I was trying to explain to you, that if you feel like, again, choosing between fixed or random, it depends on so many things, but let's say it can depend on the nature of the data, and it can also depend on your research question. Maybe some research questions will warrant that you should use fixed effects or random effects, and also the nature of the data. If you feel like the components in your data, that is the cross sections, they have some common characteristics, then you can use fixed effects. But if you feel like they don't have these common characteristics, maybe they are completely random, then you can use random effects. Again, just as I've explained here before, if you feel like these unobserved factors, this unobserved heterogeneity, which can affect the result of your variables, if you feel like it is related to your regressors, then you can use fixed effects. But if you feel like it is uncorrelated with the regressors, that is not related, then you can use random effects. But what I'm going to tell you is, okay, don't bother, I'll tell you some good news. Let's continue. So I've put there fixed, which means I'm accounting for fixed effects. Now I will just click OK, and I have my results, right? Same regression. Of course, you see my coefficients and everything. Before interpreting these coefficients, we need to check if they are statistically significant, right? Of course, you can interpret R squared, adjusted R squared, and whatever. Now, we have three things. We have pooled regression, we have fixed effect model, and we have random effects model. How do you know which to use? I've told you some examples of how you can decide what to use. But let's say you have no idea of the nature of your data, or you don't want to make this decision yourself. You want to do it statistically. So there is a test. There are two tests, actually, which we'll talk about. We'll talk about the likelihood ratio test, and we'll talk about the Hausman test. Right? Did I spell it well? Hausman test. Now, this likelihood ratio test will allow us to choose between pooled regression and fixed effects model. While the Hausman test will allow us to choose between fixed effect model and random effect model. Right? So you don't have to bother yourself to start thinking whether there are some common characteristics in your data, whether the data is completely random, whether these unobserved factors. So which one should you use? Just run all three, run pooled regression, run fixed effects, run random effects, and then use these two tests to decide which of them to use. Based on these two tests, it will tell you the one to use, and then use that one. So I'll show you now. So after running our fixed effects, this is fixed effects, right? This is results for fixed effects. Guys, give me a second. I'll take this call. Let me mute. This coffee is very sweet. Ah, thank you.
Did you prefer Oza instead?
Sorry?
It's not Oza. You can rather than Oza.
No, this one is good. It's making me feel, you know. Okay, guys. It's sweet.
You said the other is.
Yeah, I said it's nice. It's good. I love it. Ikra. When you go to the canteen, you take coffee. I always see you in the canteen. Guys, sorry. So this is fixed effects results, right? Are you guys understanding? This is results for fixed effects model.
Yeah.
So now we estimated pooled regression before, and now we have estimated fixed effects. So we want to decide between these fixed effects and pooled regression, which one is better. So we are going to use this test, likelihood ratio test, to decide between pooled and fixed effects. Now, I'll come to view. I'll come to, like you see, fixed/random effects testing down here. Fixed/random effects testing. Come to this first one, likelihood ratio. Have you seen? Click on it, and we have the results. Now, when you have these results, focus only on this part. Forget about all these things down here. We are only interested in this part. Right? Okay. I'm going to write the hypothesis for you. I'll write the hypothesis. Null hypothesis is telling us that, okay, I'll write it. Null hypothesis is telling us that fixed effects, which I will abbreviate as FE, is not appropriate. Alternative hypothesis is telling us that fixed effects is appropriate. So these are the hypotheses. Fixed effects is not appropriate. Alternative is telling us that it is appropriate. What does it mean? It means that if we reject this null and we accept this alternative, it means that fixed effects is appropriate. Therefore, it is better than pooled regression. Correct? But if we cannot reject the null, it means we are saying that fixed effect is not appropriate. So it is not better than pooled regression. So pooled regression is better than fixed effects because fixed effects is not appropriate if we cannot reject the null. So now, to perform this test again, we are going to use probability values as usual, which you can use. Okay, but now we have three things here. We have cross-section, the time series, the period, and we have both of them together. Both cross-section and period. For each of them, we have the F statistic and the chi-square statistic, right? You can forget about the chi-square and just focus on the F statistic. Most of the times, both F and chi-square, they give the same results, but you can forget about chi-square, focus on just the F. So here, for the cross-section, for this case, what is it telling us? It is telling us that cross-section fixed effect is not appropriate. You know, the null hypothesis is telling you that it is not appropriate. So for this case, it is telling you that the cross-section fixed effects, that is by accounting for fixed effects in the cross-section, it is not appropriate. Yeah, it is telling, the null hypothesis is that it is not appropriate to account for fixed effects in the period. Yeah, the null hypothesis is telling you that it is not appropriate to account for fixed effects in both of them together. So let's check the probability value. It's less than 5%, so we can reject. Yeah, we can reject. And yeah, by accounting for them together, we can reject. So you see that whether we are accounting for fixed effects in the cross-section or in the time series or in both of them together, we can reject the null. So we can reject this null and we accept this alternative. What does it mean? It means fixed effects is appropriate. Therefore, it is better than pooled, because with this test, we are comparing pooled and fixed effects. So if fixed effects is appropriate, it means it is better than pooled. So therefore, we should not do pooled regression. We should account for fixed effects based on this likelihood ratio test. Understood? So we have eliminated pooled regression. We have selected fixed. But then we need to know if fixed is better than random. This test has told us that fixed is better than put, but then we have to also compare fixed with random to know which is better. We are going to do Hausman test, right? Now, with Hausman test, before we do Hausman test, we must estimate the model with random effects. You know this model, this results, I'll go back, just come to view, come to estimation output, you have by your results. This result is with fixed effects, and we can do Hausman test with these results. It will not go. I'll try it, you'll see. With fixed effects, we should do likelihood ratio tests because we are going to compare between these fixed effects and put. But if we want to do Hausman tests, we must estimate the model with random. So let me show you something. For instance, come to view, come here. Let's try to do Hausman tests. You see, it cannot go. If you say test requires equation estimated with random. So before you do Hausman test, you must estimate the model with random. Why? Why? Because Hausman test is comparing fixed with random, right? So I'm going back to e-views. So you must not go to quick and everything. Just come here to estimate. Just click estimate. It takes you back to where you can estimate. Come to panel, and then just change this fixed to random. Just change this fixed to random. That's all. Click OK, and you have your results. This is our results now with random. We are accounting for random effects. So again, we can interpret the coefficients as we normally do. But please, before interpreting any coefficient, always make sure it is statistically significant, as you know. Of course, we can interpret a root squared, adjusted a root squared, and this kind of things. This is a result for random effects, right? Now, we are going to compare between fixed and random to see which is better. Before doing that, I'll write the hypothesis. Random effects is appropriate. Here, fixed effects is appropriate. Guys, you don't have to cram this thing. A way you can easily know it is that for both tests, for both the likelihood ratio and the Hausman test, the alternative hypothesis is the same. Fixed is appropriate, fixed is appropriate. Just here, the null is changing. Here, the null is fixed is not appropriate. The here, the null is random is appropriate. So because here we are comparing fixed and random, so the null is telling you that random is appropriate, the alternative is telling you that fixed is appropriate, but these are the hypotheses. So before we perform Hausman tests, we must estimate the model with random effects. It's a must. Because if you estimate the model with fixed effects and you try to run Hausman tests, it will not work, and we have seen. So we have estimated this model now with random effects. Come to view, come down here, and then you see Hausman test, right? You see now it's going to work, and we have the test. Again, focus just on this part. Forget about all these things down here. Focus just on this part. So you see here cross-section random, and we have the test statistic, and we have the prop value. Period random, same thing. Both of them, same thing. We cannot use the test statistic to make this result because we don't know the critical value. So as usual, we are going to use probability value because at least we know our significance levels, 5%, 10, 1. But we are using 5, right? So here, cross-section, so we are going to do it for each of them. By the way, you see the null hypothesis is telling you that random effects is not, sorry, is appropriate. Okay. So here, you see all these things are not significant. These are 1. 1 is like 100%. It's more than 5%, right? So none of them is significant, right? Since none of them is significant, it means we are unable to reject the null hypothesis. So it means random is appropriate. So the first test told us that fixed is better than put. But unfortunately for fixed, the second test has told us that random is better than fixed. So therefore, we conclude that random is the best, right? So what you can do is that in your thesis or in a paper or in whatever you're writing, do this, perform these two tests. That is, estimate pooled regression, estimate fixed effects, estimate random effects, perform the likelihood ratio test to decide which is better between pooled and fixed, and you will have the results. Perform the Hausman test to decide which is better between random and fixed, and you have the results. Report this, like create a beautiful table and report the results saying that according to likelihood ratio test, fixed is better than pooled regression. According to Hausman test, random is better than fixed. Therefore, I am using random, right? Then you would use now the random. So this is the results you will use in your thesis. So this is the results you interpret. You interpret the random. Then you need to justify why you're interpreting the results for random effects, because you have performed these two tests, and these two tests overall have told you that random is better. So you create a beautiful table and show these results, and then also show these results, and then you say based on these results, random effect is the better model to use. Therefore, we are using this model, and that is the results we are going to interpret. So you interpret these results in your paper or in your thesis. You will not interpret the results for fixed effects, and you will not interpret the results for pooled regression. But if fixed effects was better, then that's the one you interpret. So actually, you are going to have results for 3 different models. You have results for pooled regression, fixed effects, and random. But you're going to interpret just this one. In fact, you are not even supposed to even show the other ones. No need to even show the results for pooled and fixed, because why should you show results which you are not interpreting? So we are just showing only the test, the Hausman test and the likelihood ratio test. I am saying that based on this test, I have decided that random effects is the better one, is the best. So I am interpreting just random. So you will show us only these results for random, because it is the best. No need to even show the other ones, right? But that's how you can decide whether to use fixed effects or random effects or pooled. Understood? And you can interpret it. So now that it has told us that random effects is the better one, the best one, so we can interpret it. But again, always check significance. You see, this one is not significant, right? So it means labor force has no statistically significant impact on GDP in this group of countries. You know, these results are average results for this group of countries. It's panel data. So when you're interpreting your results, indicate that it is for this group of countries. Like for instance, if I'm to interpret these results, what would I say is significant so I can interpret it? Oh, by the way, this what is it? Capital. Okay, so what I can say here is that 1% increase in percent, because it is log, right? So I can say 1% increase in capital will cause 0.22% increase in GDP in this group of countries on average, because this result is for the group. In this group of countries on average, and then you can be talking about other things, maybe provided the effects of these other guys are held constant, you know, the partial regression coefficients. But know that it is on average for the group. So you can interpret your results. And you can also talk about the R squared if you want. You can say the model has a low explanatory power, the R squared is quite low. You can say the difference between R squared and adjusted R squared is 3%. You can interpret, right? You can also interpret the joint significance of the model with the F statistic, just the same interpretations we have done with ordinary least squares. But what you are supposed to do, again, I'm insisting, is that know that we have pooled regression, we have fixed effects, and we have random effects. I'm just repeating. Pooled regression is not a panel data technique. It is basic ordinary regression, ordinary least squares. We are just pulling the data together. Panel data techniques are fixed effects model and random effect model. And these techniques, we are trying to account for the spatial characteristics of our data. Now, if you run put regression, you have your results. If you run fixed effects model, you have the results. After running fixed effects model, when you have the output, perform the likelihood ratio test. This test is trying to compare between put regression and fixed effects. These are the hypotheses. Based on the results, you decide which one is better. Now, you cannot use Hausman test if you estimate the model with fixed effects. You must estimate it with random effects. So after performing this test, I will decide between put and fixed, which one is better. Next, estimate the model again with random effects. Once you have the results, run the Hausman test. The Hausman test is trying to decide between fixed effects and random effects, which one is better. These are the hypotheses. Perform the test and decide which is better. Once you perform these two tests, likelihood ratio and Hausman test, you will decide between fixed effects, random effects, and put regression, which one is better. The one which is the best, that is the one that you will report the results. But in your work, you have to show the results for these two tests so that you should explain how you have decided which model is better or best. The one which is best, that is the result you are going to analyze in your paper or in whatever you're writing. And then you can talk about the coefficient, hypothesis testing, R squared, just the same thing. But when interpreting your results, know that it is for the group. Because panel data is for a group of countries, right? It is for the group on average. So basically, I think that is it. Also, we can also check diagnostics, just like same thing. We can check, I mentioned this before, right? Cross-sectional dependence, autocorrelation, heteroscedasticity, even normality. For instance, normality is same Jagbera test. So you can perform the test. Same, you know the hypothesis, right? Null hypothesis. What's null hypothesis for Jagbera test? Yes, residuals are normally distributed. So the same thing, you can use probability value and perform the test. And then you can also check some of these tests. It will not allow you to do it because some of these tests work when you use a different method. Like for instance, in panel data, there is another method we call GMM, generalized method of moments. So if we try this one, okay, it works. There is one which will not work, if I'm mistaken. This one, I think, yes. So you think this, they say this one will not work unless you use generalized method of moments. So it will not work. But forget about GMM, it's not, at PhD you can do it. So if you have to check residuals, basically you can check normality and you can check serial correlation. Here will not work. With heteroscedasticity, this one too will not work. Okay, they say this one requires if use, whatever. If you try, some of them don't work, no problem. Use the ones that work because some of them will work with some particular methods. So that is how we can do it. Any questions? Any questions? I feel like I've not told you everything. Is there something I did not tell you? Sorry? I didn't get what you said. Why won't I answer? If you have a question, ask, I'll answer. No, I'll answer. If you have a question, I can answer.
Just please don't forget our request by extending the time. Please.
I would think. I don't know. Okay, guys. So that was that. So next week, is it next week? On Tuesday, you will do volatility.
Okay, will you extend our
with Nega Oja? You will do Ash-Gash models, guys. I can assure you, very interesting. I love volatility, very interesting. Some beautiful things you see on Osmetrics and very nice. So you did on Tuesday with Nega Oja, and then After the midterm, we are going to do time series and we'll do so many things. We'll actually do unit roots, we'll do co-integration, ARODL, you know. For this volatility, I have some personally made notes which I made myself personally for this volatility. I don't know, maybe after the midterm, we might discuss. I'll be happy to share it with you, of course. After the midterm, we might discuss. But you will do volatility with Nigahoja on Tuesday, right? No, both the lecture and the theory and the, how they call it, application, everything on Tuesday. Then you can be ready for your midterm. Okay, I'll talk to Nigahoja. I need her approval first. I cannot do anything without her approval. If she says do it, why not?
You showed us the normality test on the jug pair. It was 0.01. So it's not normally distributed because we can reject the number.
0.01 is less than 5%.
0.001.
Yes, less than 5%.
Yeah,
so you reject the null, which means not normally distributed.
So it's fine. Like, can we solve it? I mean, I know that we can solve the problem.
You know, if you face problem with normality, you can easily solve it by increasing your sample size. Or if you're not using logs, maybe logs can help. I don't know. But if you increase the sample size, you can try to solve problem with normality. But if you cannot solve it, I don't know. You know, with data, there are so many problems at times. So everything fine, right?
Thank you so much.
Okay. See you guys. Let me stop recording. I'll just leave.